There is a sea in northern Europe, not as famous as the Mediterranean, not as glamorous as tropical bays. But it is alive, it breathes, and it never truly stands still. The North Sea stretches across more than 750,000 square kilometers, bordered by the United Kingdom, Norway, Denmark, Germany, the Netherlands, Belgium, and France. It is one of the busiest and harshest seas on Earth. Here, the wind never asks permission before it blows. The weather here changes without warning. A morning may begin with pale sunlight and end beneath a storm rolling in from the Atlantic. The people who live beside the sea learn to read the sky like pages in a book. For thousands of years, people have chosen to live beside the sea. Not because it is gentle, but because it is generous. Fish, salt, trade, and even hardship all arrive from the same direction, from the sea itself. The white cliffs of Dover, an icon of Britain, are also a reflection of the North Sea's power. Every day, waves carve away a little more limestone, eroding the coast grain by grain. Never rushing, never stopping. Ancient sea charts were filled with warnings. Dangerous currents, hidden sandbanks, winter storms. The people of the past never truly conquered the sea. They learned instead how to live alongside it, season after season, tide after tide. From above, the Dutch coastline looks like an endless negotiation between humanity and the ocean. On one side, the water pushes inward. On the other, the dikes push back. And this negotiation has continued for centuries. But sometimes the North Sea knows how to be silent. Those rare and fleeting moments reveal just how beautiful this sea truly is. And in those moments, you understand why people never really leave it behind. Along the western coast of Denmark, sand is not a foundation. It is something constantly in motion. Millions of tons of sand drift with the currents each year, redrawing the coastline like an artist endlessly reshaping a masterpiece. Every grain of sand is on a long journey, from the seabed to the shore, from the shore to the dunes and back again to the sea. A cycle with no beginning and no end. Sand is never still. It is only waiting for the wind. The Rubjergnud lighthouse once stood near the shoreline to guide ships at sea. But the dunes kept advancing until, in 2019, the entire lighthouse had to be moved by crane. It was not the sea that swallowed the lighthouse, it was the sand carried by the wind. The Wadden Islands are among Europe's least known geographical wonders. These narrow strips of land are not fixed islands, but shifting structures of sand and mud constantly rewritten by tides and storms. Swlt Island loses an average of 1 meter of width every year along its western coast. This is not a metaphor, it is measured reality. Over 2 centuries, hundreds of meters of land have disappeared beneath the sea. Old maps are no longer accurate. The people living on these islands do not speak of their land as something permanent. They simply say, "The sand will go where it wants." It is not surrender, but wisdom learned through generations of watching the islands change shape. Twice each day, the tide retreats and transforms the Wadden Sea into an entirely different world. Hundreds of square kilometers of mudflats emerge beneath the sun, a vast wet desert appearing and disappearing according to the moon's schedule. Blavand, the westernmost point of Denmark, is where two ocean currents meet. Here, sand carried from the north slowly accumulates, extending the headland farther into the sea with each passing decade. Standing on these dunes at sunset, the boundaries between earth and sky, sand and water, present and past all begin to fade away. What remains is the feeling of being very small and of the sea being unimaginably old. In 1932, the Netherlands completed one of the boldest engineering projects in human history. The Afsluitdijk, a 32-kilometer barrier that sealed off an entire bay and transformed the Zuiderzee into the freshwater Lake IJsselmeer. This was not construction, it was a declaration of war against the sea. Two colors of water, two separate worlds divided by a wall of concrete. To the east lies freshwater, fertile farmland, and safe cities. To the west lies the North Sea with its storms and tides. This barrier does not only hold back water, it protects an entire way of life. But the ocean never fully surrenders. On the night of January 31st, 1953, a historic storm struck the Netherlands and shattered hundreds of dikes. Nearly 1,900 people died. Entire villages vanished beneath the sea in a single night. And afterward, the Dutch rebuilt, stronger than ever before. Delta Works, the largest flood protection project ever built, began after the 1953 disaster and took 40 years to complete. Some call it the eighth engineering wonder of the modern world. But for the Dutch, it is simply the condition required for survival. A lighthouse is not merely a tower of light. It is an admission that these waters are dangerous and people need warning. Every lighthouse along the North Sea marks a place where ships were lost and lives disappeared. Its turning light is not a greeting, but a caution. Small fishing villages along the Scottish coast have survived for centuries with the same rhythm of life. Men leave before dawn, women wait on shore. The North Sea feeds them, and sometimes it takes their loved ones away. Both realities are accepted. Kronborg Castle, where Shakespeare set the story of Hamlet, was built to control the narrowest passage between the North Sea and the Baltic. For centuries, every ship passing through these waters paid taxes to Denmark. The sea is not only nature, it is also power and wealth. The 20th century brought a new form of extraction: oil and natural gas from beneath the North Sea. Norway and Britain grew wealthy from offshore drilling. But the seabed paid the price, and winter storms remain a reminder that nobody truly controls this sea. And now humanity has found another way to harvest the North Sea, by collecting the wind itself. Thousands of offshore turbines are transforming waters once seen as obstacles into a source of green energy for all of Europe. Once again, the North Sea has become the future. Tides in the North Sea are not a small matter. In some places, the difference between high and low tide reaches 10 to 12 meters. The same beach, the same coordinates, yet only 6 hours apart, it becomes two completely different worlds. When the tide retreats across the Wadden Sea, people can walk from the German coast to distant islands kilometers away, crossing mudflats and shallow tidal channels beneath an overwhelming sky. In German, this experience even has its own name, Wattwandern, walking across the seabed. The mudflats may appear empty, but beneath every square centimeter lies a dense living community. Worms, shellfish, tiny shrimp, and fish larvae thrive here in numbers greater than many tropical forests. This is a vast natural restaurant feeding millions of birds every year. Fishermen in the small harbors of Cornwall and Yorkshire are used to seeing their boats sleeping on the sand twice a day. They do not see it as inconvenience, but as part of life's rhythm. Their schedules follow the tides, not the clock. From above, the tidal channels winding through the salt marshes resemble the veins of a giant living creature. Water flows in and out with every tide, carrying nutrients, oxygen, and life into every corner of the marsh. This is not a dead landscape, it is a beating heart. Nowhere else in the world does a sunset seem to paint itself onto the ground quite like this. When the tide retreats and the mudflats remain wet, the sky and earth merge into one. Standing there feels like floating between two heavens. The rising tide at night has a sound entirely its own. Water slipping through the grass, small waves tapping against the dikes, wind carrying the smell of salt deep inland. The people who live here know which sounds are normal and which are dangerous. It is knowledge no textbook can teach. Every year, more than 10 million migratory birds stop at the Wadden Sea to refuel before continuing toward Africa or the Arctic. It is the most important resting point along the Atlantic Flyway, an airport without a roof, operating continuously from March to October. Puffins, with their brightly colored clown-like beaks, nest inside burrows carved into the cliffs of Scotland and Norway. They dive as deep as 60 meters to catch fish and can carry dozens at once thanks to the spines inside their mouths. Small and awkward on land, yet perfectly designed for life underwater. Gray seals are among the oldest inhabitants of the North Sea. Weather, tides, and tourists hardly seem to disturb them. Resting on the sand, they resemble forgotten stones scattered across the shore, yet their dark, wet eyes quietly watch everything around them. Herring were once the silver gold of the North Sea, feeding millions of people for centuries. Vast schools stretch for kilometers beneath the water, moving like a single living organism and reflecting light in shimmering silver waves. Summer brings jellyfish closer to the shores of the North Sea. These nearly transparent creatures, with no brain, no heart, and no bones, have existed almost unchanged for more than 500 million years. They do not swim, they drift. And within that drifting exists a strange beauty beyond ordinary language. Bottlenose dolphins in the North Sea are famous for their curiosity. They often approach boats on their own, riding the waves at the bow as if playing. In Northern European fishing culture, seeing dolphins is considered a good omen. No one truly knows why they do it, and that mystery is part of what makes them fascinating. Coastal salt marshes are not considered beautiful in the traditional sense. There are no mountains, no waterfalls. But in spring, when sea lavender blooms, the entire marsh turns pale purple all the way to the horizon. A quiet beauty belonging to places few people hurry to visit. Beneath the restless surface lies a completely different world, slower, quieter, and stranger. Sea urchins, starfish, lobsters, and kelp forests form an ecosystem that most people never truly see, even if they spend their entire lives beside the sea. In the far north near the Shetland and Orkney Islands, the water is so clear that the seabed can be seen from above. These are the coldest and most nutrient-rich waters of the North Sea, where plankton thrive, fish gather, and seabirds can never seem to eat enough. There are beaches along the North Sea so vast that you can walk for an entire day without seeing another person. Not because the place has been forgotten, but because the shoreline is simply too wide, too straight, too endless to ever be filled by people. Out there, solitude is not sadness, it is simply the natural state of things. The light of the North Sea changes with the hour, the tides, the seasons, and even the humidity in the air in ways found nowhere else on Earth. 17th century Flemish and Dutch painters became so obsessed with this light that entire schools of painting were born from it, soft, diffused, never harsh, yet luminous in its own quiet way. Winter in the North Sea is the season of Atlantic storms crashing directly into the coast. Waves reaching 15 meters are not uncommon. During those days, fishermen stay home, listening to the wind howl outside while they wait. That too is part of life here. Far to the north, where the North Sea reaches the Arctic Circle, the sun does not fully set for weeks during summer. This midnight light, glowing red and gold without ever becoming dark, creates the feeling that time itself has stopped and that you are standing somewhere outside reality. The Orkney Islands, inhabited for more than 5,000 years, possess a landscape so empty it becomes haunting. No tall trees can survive the wind. Stones lie scattered as if thrown there by giants. And within that extreme openness, you begin to hear sounds you never notice in city life. Crossing the North Sea by ferry is a unique experience, hours without seeing land, surrounded only by water, waves, and a low gray sky. In that vast emptiness, many people understand for the first time what ancient sailors once described. The ocean is not a place you travel across. It is a place you exist within. From high enough above, everything becomes visible at once. The rocky coast of Scotland in the northwest, the sandy islands of Denmark in the northeast, the Dutch sea barriers in the south, and the white cliffs of Dover in the southwest. One sea, many nations, many languages, many ways of life, all shaped by the same forces: water, wind, and tides. The North Sea waits for no one. It will continue reshaping coastlines, moving dunes, feeding millions of living creatures, and challenging humanity, whether anyone is watching or not. And that is perhaps the most beautiful thing about this place. It does not need to be discovered in order to exist. It is simply there, always moving, always changing, never quite the same as yesterday. This was once an untouchable realm, a frozen desert stretching across millions of square kilometers. Nowhere on Earth was more cold or majestic, but the Arctic is changing faster than anyone ever imagined. Over the past 30 years, nearly 40% of Arctic sea ice has disappeared. Cracks are forming more frequently and spreading wider. What was once permanent ice is now fading into memory. Satellites have captured this entire transformation. Year by year, summer ice retreats, revealing deep blue waters that haven't seen sunlight for thousands of years. This is no longer a prediction. This is reality. Arctic temperatures are rising 3 times faster than the global average. Each summer grows warmer, each winter shorter. And every degree brings consequences no one fully anticipated. Beneath the surface, something even more alarming is happening. Permafrost, frozen for tens of thousands of years, is beginning to thaw. And with it, vast amounts of trapped methane are being released into the atmosphere. In the past, even in summer, the sea was still covered with thick ice. Now it is gone. And with the ice, other things have arrived, things that were never seen here before. The Arctic Ocean is no longer locked in ice as it once was. In summer, open water corridors expand like invisible highways, inviting any creature strong enough to reach them. Beneath the surface, another world is quietly shifting. The Arctic food chain, once stable for thousands of years, is beginning to tremble from the top down. And the force behind this disruption is drawing closer. This is a predator the Inuit had rarely seen in these waters, at least not in such numbers. Orca, killer whales. The ocean's apex predator, now entering a realm that was never theirs. Orcas do not hunt alone. They move in pods, coordinated, strategic, with their own forms of communication. Each pod is a perfectly evolved unit, refined over millions of years. In the past, thick sea ice formed a natural barrier, preventing orcas from entering the Arctic. They cannot breathe if the ocean surface is completely sealed by ice. But now, with open water corridors in summer, the path is clear. Orcas are among the most intelligent creatures on Earth. They recognize individuals, teach hunting skills to their young, and adapt their strategies to different prey. Their intelligence is second only to humans in many ways. An adult orca can weigh up to 6 tons and swim at speeds exceeding 55 kilometers per hour. No marine creature, not even great white sharks, dares to confront them. Orcas have no natural predators. Orcas are appearing more frequently, in waters where they were never seen before. And each sighting comes with something even more troubling. To verify, scientists began attaching satellite trackers to orcas. The data shocked everyone. Orcas from the Atlantic are migrating into the Arctic every summer, and they are staying longer each year. Each point on the map marks an orca sighting, and those points are increasing year after year. They are not just passing through, they are settling. The Arctic is becoming their new territory. Beneath the freezing Arctic waters, orcas are surveying their new domain. Using echolocation, they scan their surroundings, each returning signal forming a precise image of potential prey. Seals once found safety on floating ice. But orcas have learned to create waves to wash them into the water, a sophisticated technique developed in southern oceans and now brought north. They arrive, they hunt, and they leave behind a transformed ocean. The presence of orcas is not just an ecological event. It is a warning that the entire system is shifting from the top down. In ecology, when an apex predator changes, everything below is affected. Not gradually, but like a chain reaction. And the Arctic has never seen a predator like this before. They are called the unicorns of the ocean. Narwhals, with their long spiral tusks, are among the most mysterious creatures on Earth. They evolved to live in the coldest, most remote, and until recently safest places on the planet. Narwhals spend most of their lives beneath the sea ice, where no predator could reach them. They are among the most specialized Arctic species, unable to survive elsewhere, unable to adapt to warmer environments. For thousands of years, narwhals have depended on one thing: sea ice. It is their shelter, their shield, their boundary from the outside world. But that shield is disappearing. As the ice melts, narwhals are pushed into open waters, where they have no defense. Thousands of years without predators have left them unprepared, unable to escape, unable to react when danger strikes. The moment orcas detect narwhals, the outcome is already decided. Using echolocation, they determine position, speed, and numbers. Then they begin to encircle silently, precisely, without mercy. Narwhals respond with the only instinct they have: flee toward the ice. But the ice is no longer thick enough, no longer vast enough. And orcas are faster, far faster than anything narwhals have ever faced. For the first time on record, scientists witnessed orcas killing multiple narwhals in a single coordinated attack. Not just one, but many. The efficiency is terrifying. When a tracked narwhal satellite signal suddenly goes silent, scientists know what has happened. Each disappearing signal marks a life lost. And those signals are vanishing more frequently. Narwhal behavior is changing. They move less, stay closer to the ice, and form smaller groups. These are signs of a species learning to live with a fear their ancestors never knew. Data reveals a clear correlation. As orca sightings increase each year, narwhal populations decline in certain regions. This is no longer speculation. It is evidence of a crisis unfolding. Narwhals have existed for millions of years. They survived ice ages and geological shifts. But can they survive a new predator from the south, one brought in by climate change? Typically, ecological change begins at the bottom. When algae decline, crustaceans decline, then fish and eventually larger animals are affected. This is the pattern science understands. But in the Arctic today, the opposite is happening. Ecologists call this a top-down cascade, a chain reaction from the top of the food web downward. When apex predators change behavior, every level below responds. And this time, the driver is not native, it is an outsider. Polar bears are already suffering from melting ice. Now they face an indirect threat. Orcas are competing for their food, seals, and small whales, which are essential to their survival. Seals, once active hunters of fish and crustaceans, are becoming more cautious, spending less time in the water. Their behavior is shifting due to fear of orcas. And when seals feed less, fish populations may rise in unpredictable ways. When mid-level predators are suppressed, their prey can explode in numbers. It may seem beneficial, but it is not. Surging fish populations can deplete lower food sources, leading to a collapse of the entire supply chain. This is the most frightening aspect of ecology, a chain reaction that cannot be stopped once it begins. Each affected species influences another, creating consequences that even advanced models struggle to predict. Scientists from Norway, Canada, Denmark, and the United States are combining data to build a complete picture. Alongside Inuit knowledge, they are trying to understand something never fully described before: an ecosystem being reshaped in real time. A stable ecosystem takes thousands of years to form. Species find their roles, balance is established, and energy flows consistently. But that stability can be broken in decades, even years, if a key element suddenly changes. Orcas do not know they are disrupting a system thousands of years in the making. They are simply following evolution, hunting, reproducing, expanding their range. The tragedy is not the orca, but what has opened the door for them. By recording orca calls, scientists can identify individuals, track their movements, and even predict where they may go next. Each orca has a unique voice, like a human fingerprint. Climate models predict that by mid-century, the Arctic could be nearly ice-free in summer. This means open corridors for orcas lasting months, with no barriers preventing them from exploring the entire Arctic Ocean. The future of narwhals depends on a single factor: can humans slow climate change? If ice continues to melt at the current rate, some populations may not survive to the end of this century. This is the Arctic of the 21st century, no longer the frozen constant we once knew. It is a new arena, where old rules no longer apply and new ones have yet to be written. Earth's newest competition has begun. Climate change does more than melt ice. It opens doors never meant to open, bringing new predators into places that never knew them. The Arctic is becoming one of Earth's greatest lessons, if we are still willing to listen. Most of Earth's surface is not land, but water. These vast oceans hold unmatched power. This is a journey into the most extreme forces of nature on our planet. Nowhere on Earth does nature display its power more clearly than here. These waves are not only beautiful, they carry destructive energy. And yet, humans continue to venture out to sea. Every voyage is a confrontation with the unknown. No technology can eliminate the ocean's risks entirely. Only skill, discipline, and a measure of luck bring people safely home. Beneath the surface, massive ocean currents silently move millions of tons of water each second. They regulate Earth's climate and sustain billions of lives. Yet they can also tear a ship apart like paper. Thousands of years ago, humans ventured into the ocean with fragile wooden boats. No GPS, no forecasts, no communication, only the sky and instinct. That spirit has never left humanity. Today, technology allows us to see what is coming, but not to stop it. A single ocean storm can store energy equal to thousands of nuclear bombs. And it needs no reason to change course. More than 80% of the ocean remains unexplored, more than the surface of the moon. We know less about the seafloor than about Mars. This is not a failure of science, but proof of Earth's endless mystery. The Atlantic Ocean has witnessed humanity's greatest conquests, discoveries, and disasters. It connects continents, yet stands as a boundary between life and death. No ocean is more unpredictable than this one. With no warning, calm can turn into chaos within an hour. Even the most experienced sailors respect the Atlantic's unpredictability. This is an ocean no one dares to underestimate. Each hurricane season, the Atlantic generates dozens of tropical storms, some becoming massive hurricanes. They draw energy from warm waters and transform into engines of destruction. No human structure can withstand a Category 5 storm. In 1912, the unsinkable ship sank on its maiden voyage. The Titanic became a symbol of human arrogance against the ocean and its cost. Over 1,500 lives were lost in the freezing North Atlantic night. Conflicting currents can generate rogue waves, appearing without warning and reaching up to 30 meters. They can sink large ships in seconds. Once considered myth, they are now confirmed by science. The Bermuda Triangle, where ships and aircraft have vanished without a trace. Science offers explanations, yet the ocean still holds mysteries beyond our understanding. Climate change is warming ocean waters, leading to stronger and more frequent storms. Scientists predict a significant rise in Category 4 and 5 hurricanes this century. The Atlantic is becoming more dangerous over time. Despite the danger, some still venture out to save others. Rescue teams face the harshest conditions nature can create. Courage is not the absence of fear, but action in spite of it. If you gathered all continents together, they still would not fill the Pacific Ocean. It is the largest, deepest, and most mysterious ocean on Earth. Beneath it, geological forces reshape our planet every day. Pacific superstorms, known as typhoons, are the most intense storms on Earth. Typhoon Haiyan in 2013 reached winds of 315 kilometers per hour as it struck the Philippines. Over 6,000 lives were lost in less than 24 hours. The Pacific Ring of Fire is the most geologically active region on Earth. Over 75% of volcanoes and 90% of major earthquakes occur here. Tectonic plates constantly collide and subduct beneath one another. In 2004, an undersea earthquake triggered the deadliest tsunami in modern history. Waves traveled at jet speed, claiming over 230,000 lives. There was no warning, only the sea pulling back, then rushing in. El Niño, meaning the child in Spanish, is a climate phenomenon driven by the Pacific. When warm waters spread, they trigger droughts, floods, and global climate shifts. One ocean can reshape the world. The same ocean that creates typhoons also sustains the most beautiful ecosystems on Earth. The Great Barrier Reef is the largest living structure on the planet, visible from space. Yet it is slowly dying as ocean temperatures rise. Below 200 meters, sunlight disappears. This is another world, cold, dark, and silent. Humans can only reach it with technology, and even then, it is never completely safe. Yet some choose to cross the Pacific alone in a kayak, simply to prove it can be done. Sarah Outen and Roz Savage seek not fame, but their own limits. And the ocean is the harshest teacher they have ever faced. At the southern tip of South America, where two oceans meet, lies Cape Horn, the end of the world. For centuries, it has been the nightmare of sailors. Not all who reach it succeed, and not all who succeed return. Where the Atlantic and Pacific collide, waves stack from opposing directions. They defy patterns, rising unpredictably into towering peaks. Winds often exceed 200 kilometers per hour, known by sailors as the roaring winds. Before the Panama Canal, Cape Horn was the only route between oceans. Hundreds of ships risked their lives each year to pass it. These waters have claimed countless vessels and some of the bravest sailors in history. Beyond waves and wind, icebergs pose a third deadly threat. Drifting from Antarctica, most remain hidden beneath the surface. A single collision in the dark can end a journey instantly. Among sailors, solo navigation around Cape Horn is the ultimate test. Not for pride, but as a reminder they did not turn away from fear. Rarely, Cape Horn offers a moment of peace. The sea becomes still, sunlight reflects across its surface, and the air is crisp and pure. It is a reward for those with enough patience and enough luck. At the southernmost point of the planet lies the last continent humans reached, Antarctica. It is the coldest, windiest, and driest place on Earth, and the largest desert. No one truly lives here. Nothing lasts here except ice and mystery. Roald Amundsen and Robert Falcon Scott raced to this point of no return in 1911. Amundsen made it back. Scott did not. He and his team perished in a blizzard just 18 kilometers from safety. Antarctica does not forgive mistakes. It never has. Antarctic blizzards can form within minutes and last for days. Winds can reach 320 kilometers per hour, turning everything into a single white void. Leaving shelter without guidance in such conditions is a mistake you only make once. Antarctic waters produce the largest icebergs ever recorded, larger than entire countries. As they break and drift, they become hazards across thousands of kilometers. Beneath the surface, most of their mass remains hidden. Amid this harshness, life persists. Emperor penguins. They raise their young at -60 degrees Celsius in darkness and storms. If they can endure this, resilience is not unique to humans. Crevasses are hidden traps, plunging dozens of meters deep beneath thin snow. They offer no warning. Many explorers have fallen into these icy voids, never to be seen again. Yet Antarctica also holds indescribable beauty. The aurora australis transforms the night sky into flowing curtains of light. Here, violence and beauty coexist inseparable. If Mount Everest were placed into the Mariana Trench, its peak would still be over 2 kilometers below the surface. This is the deepest point on Earth, 11,034 meters below sea level. Humans have only visited it a handful of times. In 2012, James Cameron descended alone to the deepest point on Earth. He spent nearly 3 hours in a vessel enduring pressures 1,000 times greater than at the surface. What he found was not emptiness, but a surprisingly vibrant world. In a place without light, with little oxygen, and crushing pressure, life still thrives. These organisms have evolved to survive extreme conditions. They prove that life does not need perfection, only opportunity. Bioluminescence is the language of creatures that have never seen the sun. They use light to hunt, communicate, and attract mates. Each species has its own light code, evolved over millions of years in darkness. On the ocean floor, geothermal energy escapes through hydrothermal vents. Around them exist rich ecosystems that do not rely on sunlight. These may hold clues to the origin of life on Earth and possibly beyond. Every sample from the Mariana Trench may contain unknown biological compounds. These could lead to new medicines or deeper insights into life. The deep ocean is a treasure we have yet to unlock. But when humans reached the deepest point on Earth, what did they find? Plastic bag. Our waste arrived before we did. The ocean is not just a place to explore. It is a mirror reflecting what we are doing to our planet. Most volcanic activity on Earth occurs beneath the ocean, hidden from human sight. Lava forms the longest mountain ranges on the planet, like the Mid-Atlantic Ridge stretching over 70,000 kilometers. Earth is constantly reshaping itself in the darkness below. Nearly every deep-sea expedition reveals new species. Millions of organisms remain undescribed and unnamed. We share this planet with life forms we have yet to discover. Remotely operated vehicles, or ROVs, have opened a new era of ocean exploration. They reach places humans cannot and return images that reshape science. Yet even now, we have seen only a fraction of what lies below. The seafloor is a vast archive of Earth's history, its sediments recording ancient eras. Within them are microorganisms that have survived since the age of dinosaurs and still live today. It is the greatest natural library, and we have only read its first pages. From the restless Atlantic to the powerful Pacific, from the harsh Cape Horn to the depths of the Mariana Trench. The ocean is not a postcard backdrop. It is the most dynamic force on this planet. It creates life, sustains life, and can erase it in a single moment of fury. Humans do not go to sea for safety. No one seeks safety where none exists. They go because the ocean calls them, because beyond the horizon lies the unknown. It is humanity's oldest instinct, to be curious, to explore, to move forward. We call this planet Earth, yet 71% of it is water. The ocean is not a part of Earth, Earth is a part of the ocean. And the journey to explore it, no matter how dangerous or unfinished, is still ongoing. There is a moment when you stand before the ocean and feel that everything is safe. The water is perfectly still. The light is soft. The wind is gentle. And yet, it may be the most dangerous moment you have ever experienced, without even realizing it. For centuries, humanity learned to read the sky to predict danger. Dark clouds, violent winds, towering waves, the familiar signs of an approaching storm. But the ocean's true enemies never reveal themselves. Beneath every calm ocean surface lies a massive system constantly in motion. Currents, thermal layers, immense pressure, all existing in silence. The ocean does not need storms to become deadly. There are oceans on this planet that humanity has misunderstood for centuries. Not because they are loud or violent, but because they are too silent, too deep, too cold. This is a journey into those places. The greatest danger of the ocean is not what we can see. It is the invisible forces surrounding us every second, every minute. And by the time you notice them, it is usually too late. This is not a story about monsters or storms. This is a story about invisible forces that science is only beginning to understand, and about the absolute smallness of humanity before the true ocean. The Black Sea appears no different from any other ocean from above. Deep blue water, sometimes rough, sometimes calm like a lake. But beneath its surface lies one of the strangest structures on this planet. The Black Sea is divided into two completely separate worlds by an invisible boundary. Above it, light and oxygen still exist. Below it lies a dead zone. More than 80% of the Black Sea's volume is filled with highly toxic hydrogen sulfide gas. Hydrogen sulfide, the gas known for its rotten egg smell, has accumulated here for thousands of years with nowhere to escape. No ordinary bacteria can survive there. No creature can breathe. It is one of the largest dead marine zones ever created by nature. The boundary between these two layers is called the chemocline, an invisible transition zone. Cross just a few dozen meters downward, and you move from a living world into a dead one. No warning signs, no visible color change. Nothing at all. Because there is no oxygen, no organism can decompose material at the bottom of the Black Sea. Shipwrecks that sank thousands of years ago remain almost perfectly preserved. The Black Sea is a perfect graveyard and a reminder of the terrifying power of invisible boundaries. The entire ecosystem of the Black Sea survives within a thin upper layer only about 150 meters deep. Beneath it, there are no fish, no plants, nothing we would recognize as life. A boundary so thin it becomes terrifying. From the surface, the Black Sea looks completely harmless on an autumn evening. No one can see the toxic layer below. No one can feel that invisible boundary. That is the nature of unseen dangers. They never need to reveal themselves. The Red Sea is one of the most beautiful oceans on Earth, and also one of the harshest. surrounded by deserts and exposed to scorching sunlight for hundreds of days each year. Its beauty is only the outer layer of an extreme environmental system. The Red Sea receives very little freshwater, while evaporation intensifies under extreme heat. As a result, its salinity ranks among the highest in the world, placing enormous stress on every form of life. The water here is not only hot, it feels dense, heavy, and difficult to survive in. At the bottom of the Red Sea exist formations known as brine pools, ultrasaline lakes beneath the ocean. They are many times saltier than normal seawater, so dense that objects seem to float on them like a solid surface. And they contain chemicals capable of killing living organisms within minutes. Surface temperatures in the Red Sea during summer can reach up to 34 degrees Celsius. For divers, that level of heat can cause dehydration and exhaustion surprisingly fast, even without intense activity. The danger of the Red Sea does not come from storms. It comes from a harsh environment working silently over time. The beauty of the Red Sea's coral reefs makes people forget where they truly are. A sea trapped between two arid continents, far from rescue, unusually hot and intensely salty. The ocean is often most beautiful in the places where it is also most dangerous. When the sun sets over the Red Sea, the air cools, but the water still holds the heat of the day. The temperature difference creates strange air movements and unpredictable currents. Silence does not mean safety. It never has. Between the tip of South America and the northern edge of Antarctica lies only 800 kilometers of water. But within that narrow space, the Atlantic, Pacific, and Southern Oceans collide. The Drake Passage is where some of the most powerful oceanic forces on Earth converge. Waves in the Drake Passage regularly reach heights of 10 to 15 meters, taller than a four-story building. Winds blow endlessly without being blocked by any continent, gathering energy across thousands of kilometers. Every wave is the result of a journey around Antarctica itself. Conditions in the Drake Passage can transform completely within just a few hours. The sea may appear manageable in the morning, then become a nightmare of massive waves by afternoon. No forecasting system can perfectly predict such extreme changes. Beneath the waves flows the Antarctic Circumpolar Current, the most powerful current on Earth. It carries a volume of water 150 times greater than all the world's rivers combined. Nothing can resist it, and there is nowhere to hide between the ends of the planet. Icebergs add yet another danger to the Drake Passage, most of their mass hidden beneath the surface. Radar cannot always detect them through heavy fog and violent seas. A multi-million-ton object, nearly invisible, moving directly toward your ship. Those who have crossed the Drake Passage often say there are no words capable of describing the experience. It is not fear. It is the overwhelming realization of how small humanity truly is. The Drake Passage does not care who you are. It never has. The Bering Sea lies between Alaska and Siberia, where two completely different geographic worlds collide. In winter, it becomes one of the harshest places humans have ever entered. But not because it is constantly violent, rather because it can change without warning. Ice accumulation on ships is one of the least understood dangers of the Bering Sea. Freezing salt spray rapidly builds across every surface, adding weight and destroying balance. Within hours, a stable vessel can become impossible to control. Blizzards in the Bering Sea can reduce visibility to less than 10 meters within minutes. Radar becomes distorted by snow and salt. GPS signals may fail under extreme conditions. You no longer know where you are going, and no one else knows where you are. Yet the Bering Sea is also one of the richest ecosystems on Earth. Millions of seabirds, whales, seals, and salmon depend on its immense supply of nutrients. Here, life and death exist side by side, separated only by a sudden change in weather. The deadliest aspect of the Bering Sea is not the storms, but the speed of change. Temperatures can drop by 15 degrees within hours. Winds can double in strength within minutes. The human body cannot adapt to change at that pace. In the middle of winter, the Bering Sea receives only a few hours of daylight. The rest is total darkness, blizzards, and waves you can hear but cannot see. Losing your sense of direction in darkness at sea is a danger no technology can fully overcome. Cape Horn is the southernmost point of the Americas, a lonely rock rising from a violent ocean. For centuries, every ship traveling between the Atlantic and Pacific had to pass this point. And the passage demanded a terrible price. More than 800 ships are believed to have sunk in these waters. The seafloor around Cape Horn is what makes the waves here exceptionally chaotic. Deep ocean water suddenly collides with shallow regions, compressing wave energy into violent and unpredictable bursts. A single wave can split into several smaller waves moving in completely different directions. The winds around Cape Horn carry terrifying names: the Roaring Forties and the Furious 50s. These names are not poetry. They are lessons written in the survival stories of sailors. The wind does not merely blow hard. It changes direction without warning, destroying every navigation plan. There is a lighthouse on Cape Horn, one of the loneliest stations on Earth. Its keeper lives there for months, watching the sea, sometimes witnessing ships sink with no ability to help. Not because of a lack of skill, but because the distance between humans and rescue becomes meaningless here. Sailors say that surviving Cape Horn is one of the greatest achievements in maritime history. Not because it is distant, but because nature leaves you with no advantage there. Cape Horn, everything favors the ocean, never you. The Arctic Ocean is the smallest ocean on Earth, yet dangerous in ways few people truly understand. Not because of storms, not because of giant waves, but because of the cold, the darkness, and the absolute isolation. This is a place where the nearest rescue may take days to arrive. When the human body touches near-freezing water, the first reaction is an uncontrollable gasp for air. If you are already falling beneath the surface, that single breath can fill your lungs with water instantly. No deep ocean is required. No giant wave. Only the moment you enter the water. In water near 0 degrees Celsius, a healthy adult may lose consciousness within roughly 15 minutes. No swimming skill can extend survival for very long. No determination can overcome human physiology. This is not weakness. It is the physical limit of the human body. During winter, large regions of the Arctic Ocean receive no sunlight for weeks at a time. Total darkness. Temperatures below -40 degrees. Ice that can fracture without warning beneath your feet. This is an environment humans were never evolved to survive in. Humanity built nuclear icebreakers in an attempt to conquer the Arctic Ocean. Massive ships weighing tens of thousands of tons, powered by engines stronger than many warships. And still, they move only a few kilometers per hour. The ocean has not been conquered. It is merely tolerating us. The Southern Ocean is the only ocean on Earth that completely circles a continent without interruption by land. Winds and waves can travel around the planet without anything stopping them. That is why the energy here never truly dissipates. The waves of the Southern Ocean are unlike anywhere else on Earth. They do not immediately crash. They rise as massive moving walls of water. The result of thousands of kilometers of open ocean where energy never fades away. The Antarctic Circumpolar Current is the most powerful current on the planet. It moves around 130 million cubic meters of water every second, more than 100 times the flow of all rivers on Earth combined. Nothing was designed to remain still inside such a system. Even scientists working in the Southern Ocean describe it with a unique sense of fear and respect. Not because they are unprepared, but because no preparation can ever be enough for a place like this. Knowledge cannot overcome distance. And here, distance is the real enemy. Sometimes the Southern Ocean reveals a beauty found nowhere else on Earth. Aurora lights reflecting across the water. Stars burning bright in skies untouched by human light. But this beauty is not an invitation. It is nature's complete indifference to your existence. The Southern Ocean is not only dangerous, it is the heart of the planet's global ocean circulation system. Cold water sinks here and travels across the world's oceans. What happens in this region affects the climate of the entire planet every single day. We taught our children that rough seas are dangerous while calm seas are safe. But the Black Sea teaches us that danger can exist within invisible layers. The Red Sea teaches us that extreme environments do not need violence. They only need time. Drake Passage and Cape Horn teach us that sudden change is more dangerous than a storm we can predict. The Arctic Ocean teaches us that isolation and cold can kill faster than any wave. The Southern Ocean reminds us that some places on Earth were never meant for human presence. The ocean is not our enemy. It is simply itself vast, ancient, and completely indifferent. The greatest danger is not what we can see, but what we believe we already understand. And perhaps the wisest lesson humanity can learn from the ocean is knowing what truly deserves our fear and respect. In the middle of the Atlantic Ocean lies a region known for centuries, yet never fully understood. Dozens of ships and aircraft have vanished without a trace. No wreckage, no debris, no clear explanation. This is the story of one of the greatest mysteries that modern science has yet to fully solve. The Bermuda Triangle spans more than 1.1 million square kilometers and lies along one of the busiest shipping and aviation routes between the Americas and Europe. Within this region lies the Puerto Rico Trench, the deepest point in the Atlantic Ocean at 8,376 meters, where sunlight never reaches and pressure is immense enough to crush ships instantly. The powerful Gulf Stream flows through the region at speeds up to 9 kilometers per hour, strong enough to scatter debris within hours. The seafloor also changes dramatically from shallow continental shelves to deep ocean trenches, creating unpredictable currents and underwater turbulence. The Bermuda Triangle sits within one of the most active hurricane zones on Earth. Between 8 and 12 major storms pass through this region every year. Calm skies can transform into violent storms within minutes. One of the earliest historical accounts comes from Christopher Columbus. In 1492, he reported strange compass readings and mysterious lights beneath the ocean surface. He also described a fireball falling into the sea while passing through the region. Bermuda is one of the few places on Earth where magnetic north and true north align. This unusual phenomenon can confuse navigators unfamiliar with the region. The Bermuda Triangle lies near the boundaries of several tectonic plates. Underwater earthquakes and volcanic activity can cause sudden disturbances beneath the ocean floor. Weather satellites have observed unusual hexagonal cloud formations in the region. Scientists believe these clouds may generate powerful air bombs, intense downdrafts that strike the ocean surface. Massive methane hydrate deposits exist beneath the seafloor. When released suddenly, the gas bubbles can reduce water density, potentially causing ships to lose buoyancy and sink rapidly. Since the 1800s, more than 50 ships and 20 aircraft have reportedly disappeared in the Bermuda Triangle, taking over 1,000 lives with them. On December 5, 1945, Flight 19, a squadron of 5 TBF Avenger aircraft, departed from Fort Lauderdale on a routine training mission. 14 experienced pilots, clear weather, and full fuel tanks. There was no reason for concern. None of them knew this would be their final flight. All 5 aircraft disappeared without a trace, leaving behind no wreckage. 2 hours after takeoff, the leader of Flight 19 transmitted a distress message. "We cannot determine our position. We don't know where we are. The ocean looks strange." The compasses on all 5 aircraft began spinning wildly. The final signal was recorded at 7:04 p.m. After that, there was only silence. The U.S. Navy launched a massive search operation involving hundreds of ships and aircraft. A rescue plane, a PBM Mariner carrying 13 crew members, also disappeared that same night. A nearby tanker reported seeing a large explosion in the sky. No wreckage was ever recovered. In March 1918, the USS Cyclops left Barbados carrying 309 people and over 10,000 tons of manganese ore. The massive ship vanished completely on its way to Baltimore. No distress signal, no wreckage, no bodies were ever found. President Woodrow Wilson later said, Only God and the sea know what happened to that ship. In December 1948, a DC-3 carrying 32 passengers from Puerto Rico to Miami vanished just 50 miles from Miami. The weather was perfect and the final radio transmission sounded completely normal. There were no signs of trouble before the aircraft disappeared. In 1881, the merchant ship Ellen Austin discovered an abandoned sailing vessel drifting at sea. The sails were intact and the cargo untouched, yet there was not a single person aboard. When a small crew was sent to guide the ghost ship back to port, it vanished into the fog only a day later. The Mary Celeste, perhaps the most famous ghost ship in maritime history, was found drifting in 1872. Food was still on the table, a glass of wine remained untouched, and personal belongings were left behind. Yet all 10 people aboard had completely vanished. Within just 13 months, British South American Airways lost 2 Tudor IV aircraft in the Bermuda Triangle, Star Tiger in 1948 and Star Ariel in 1949. Both aircraft disappeared without leaving any trace. In December 1967, the yacht Witchcraft contacted the Coast Guard after a minor collision just 1 mile from Miami. 19 minutes later, rescuers arrived at the location, but the vessel had completely vanished. Joshua Slocum, the first man to sail solo around the world, disappeared in 1909 while traveling through the Bermuda region. Neither he nor his vessel, the Spray, was ever found. Many pilots and captains who survived reported strange phenomena: spinning compasses, sudden electronic failures, and a white haze surrounding the aircraft or ship. Some managed to escape the region, but many others never did. Lloyd's of London, the world's oldest maritime insurance institution, has handled numerous disappearance claims in this region for over a century. Insurance premiums for ships traveling through the area are often significantly higher than for other routes. The Puerto Rico Trench, descending 8,376 meters, is one of the darkest and most mysterious places on Earth. Humanity has explored less than 20% of the global ocean floor. The rest remains an unknown abyss. Within that darkness, what exists may be far beyond the imagination of modern science. The giant squid Architeuthis lives between 300 and 1,000 meters deep. Until 2004, humanity had never captured a live image of this creature. We only knew it through washed-ashore carcasses and massive sucker marks found on sperm whales. Sonar systems on several research vessels have detected unusual echoes, objects moving with speeds and trajectories that do not match known marine life. In 1997, NOAA recorded a mysterious underwater sound known as the bloop, audible across thousands of kilometers. The Greenland shark can live up to 500 years and swims at depths exceeding 2,000 meters. A shark alive today may have already existed when Columbus crossed the Atlantic. These creatures move slowly and silently through the dark ocean. Many divers and sailors have reported sightings of massive sea creatures measuring between 15 and 30 meters long. Some do not match any known species. History has shown that creatures once believed extinct may still survive in the deep ocean. The deep ocean hosts some of the strangest life forms on the planet. Many species have yet to be named or classified. Scientists estimate that over 90% of marine life remains undiscovered. Deep-sea exploration robots have occasionally recorded unusual rock formations arranged in seemingly geometric patterns on the seafloor. Are these rare geological structures, or traces of something else entirely. Beneath the calm surface lies a complex system of massive underwater vortices. These currents can drag objects hundreds of meters downward and carry them across vast distances. Deep beneath the ocean live microorganisms that require no sunlight at all. They survive by drawing energy from chemical reactions between rock and water. These organisms may represent some of the oldest ecosystems on Earth. Some scientists suggest the deep ocean may hide descendants of ancient marine creatures. The deep sea is one of the most stable environments on Earth, changing very little over millions of years. Along tectonic plate boundaries, hydrothermal vents release superheated water reaching temperatures of 400 degrees Celsius. Around them exists a unique ecosystem that thrives without sunlight. Some researchers believe low-frequency infrasound waves may disorient humans. These frequencies can influence the brain and visual perception, creating confusion and panic. Scientific expeditions reveal that the deep ocean remains the largest unexplored frontier on Earth. In fact, scientists often admit that humanity knows more about the surface of Mars than about the depths of our own oceans. In 1968, diver Joseph Valentine discovered the Bimini Road, massive limestone blocks arranged in a straight line beneath the waters near Bimini in the Bahamas. The formation stretches nearly 800 meters, with some stones weighing up to 25 tons. Some geologists argue the formation is natural beach rock fractured over time. However, others point out that several stones have sharp angles and flat surfaces resembling human construction. 12,000 years ago, global sea levels were about 120 meters lower than today. Vast regions now submerged beneath the ocean were once dry land. Sonar images of the Bahamian seafloor reveal unusual geometric patterns, squares and rectangles hidden beneath sand and coral. Some researchers believe these formations resemble ancient structures. Some sonar reports have suggested the presence of pyramid-like structures beneath the ocean near Bermuda. If confirmed, they could be larger than the Great Pyramid of Giza. Some researchers believe the positions of ancient pyramids around the world may align along specific meridian lines. The philosopher Plato once wrote about Atlantis, a powerful civilization in the Atlantic Ocean that vanished beneath the sea after a catastrophic disaster. Some divers have reported hexagonal stone pillars arranged in circular formations on the Bahamian seabed. Their geometric shapes raise questions about their origin. Independent researchers have claimed to find stone tools and ceramic fragments beneath the Caribbean seafloor. If verified, these artifacts could date back more than 10,000 years. Edgar Cayce once predicted that remnants of Atlantis would be discovered near Bimini in the late 1960s. In 1968, the Bimini Road was found. Some authors have proposed that ancient technology might generate energy fields capable of disrupting electronic devices. However, this idea is not supported by mainstream science. In 2001, a research team reported discovering large underwater structures off the coast of Cuba at a depth of around 700 meters. Sonar images appeared to show shapes resembling streets and plazas. Some researchers believe that certain seabed survey data has never been widely released. This has fueled speculation about what might truly lie beneath the region. High-resolution sonar, deep-sea robots, and artificial intelligence are now helping scientists explore the ocean in unprecedented detail. The Bermuda Triangle remains there, calm and mysterious in the Atlantic Ocean. What lies beneath its deep blue waters may remain one of the greatest mysteries of the sea. On the world map, there is a narrow strip of water less than 33 kilometers wide, so small it is easy to overlook. Yet every day, 30% of the world's oil passes through here. It is called the lifeline of civilization. Every day, around 21 million barrels of oil silently pass through here, carried by massive tankers longer than 3 football fields. They come from the oil fields of Arabia and travel to every corner of the world. There is no alternative route. The Strait of Hormuz lies between Iran and the Arabian Peninsula, a single gateway connecting the Persian Gulf to the Indian Ocean. Its full width is 33 kilometers, but the actual shipping lanes are only about 3 kilometers each way. It is one of the most closely monitored geographic spaces on Earth. Thousands of years ago, Arab traders sailed these waters, carrying spices, pearls, and silk to India. Hormuz was once an independent trading empire where sea routes converged. Its role has changed, but its importance has never diminished. The human body can survive weeks without food and days without water, but only minutes without breathing. The global economy is the same. It can endure many shocks, but it cannot survive if Hormuz is closed. That is why this place is called the throat of the world. "21 million barrels of oil. That is what the Strait of Hormuz must digest every single day. If poured into Olympic swimming pools, it would fill over 30,000 of them. No other oil transit route on Earth comes close to this scale. China is the world's largest oil importer, and much of it must pass through Hormuz. Every factory running, every car moving, every building being heated in China is tied to this narrow stretch of water. It is a geographic dependency Beijing has never been comfortable with. Japan imports over 90% of its oil through Hormuz. With no significant domestic energy and no pipeline alternatives, it relies entirely on tankers and a single strait. South Korea faces a similar reality. For both nations, Hormuz is not a choice, it is geographic destiny. If supply through Hormuz is disrupted for just a few days, global oil prices could surge by tens of % within 24 hours. And when oil rises, everything rises: transport, manufacturing, food, electricity. The global supply chain tightens like a body cut off from its blood flow. We often think of oil as fuel for cars or planes. But it is also the foundation of plastics, fertilizers, pesticides, paints, synthetic fabrics, and thousands of other products. Half the items in the room you are in contain petroleum derivatives. Hormuz doesn't just carry fuel, it carries modern industry itself. India, one of the fastest-growing economies in the world, is also increasing its dependence on Gulf oil. The Jamnagar refinery processes over 1 million barrels a day, most of it arriving through Hormuz. The prosperity of hundreds of millions of Indians is anchored to a strait thousands of nautical miles from Mumbai. The northern shore of the strait belongs to Iran, the country that controls much of this strategic waterway. From here, every passing vessel is within sight, radar range, and if necessary, missile range of Tehran. It is one of the rare geographic advantages Iran holds in the global geopolitical game. Along Iran's coastline, anti-ship missiles like Noor and Khalij-Fars are positioned on rugged mountain terrain. They can strike targets hundreds of kilometers away, and within the narrow confines of Hormuz, no vessel can escape their range. This is asymmetric warfare, low cost, high destructive impact. Iran does not rely only on exposed weapons. Inside coastal mountain ranges, underground bases carved into rockhouse fast boats, missiles, and command centers. Satellite imagery cannot fully reveal them. Conventional bombs cannot easily penetrate them. This is a hidden card Iran holds, and its adversaries know it well. A $13 billion U.S. aircraft carrier can be overwhelmed by hundreds of small speedboats worth only tens of thousands each. This is the swarm tactic Iran has practiced for decades, attacking simultaneously from all directions with speed and overwhelming numbers. In the narrow waters of Hormuz, traditional technological superiority becomes ineffective. Beneath the strait, where no human eye can see, Iran could deploy thousands of naval mines within hours. A single mine can tear open the hull of a supertanker. And once a few ships are damaged or sunk, the entire route can be shut down, not by force but by fear. It is one of the most effective psychological weapons in Hormuz. In response, the United States Navy maintains a constant military presence in the Gulf and the Strait. The Fifth Fleet, based in Bahrain, patrols 24/7, with ships, radar, and satellites tracking every movement. It is a never-ending mutual surveillance, and both sides know a single mistake could trigger disaster. What sounds like a hypothesis has already happened multiple times. In 2019, several oil tankers were attacked near Hormuz, their hulls breached and crews thrown into panic. Oil prices spiked instantly, and global financial markets trembled. Just a few attacks, without full-scale war, were enough to trigger worldwide economic anxiety. In summer, temperatures in Hormuz can exceed 50 degrees Celsius. The sea becomes a mirror reflecting intense heat, and metal surfaces on ships can burn skin on contact. Crews work in conditions nearly beyond human tolerance, while electronic systems frequently fail under extreme temperatures. From the Arabian Desert, massive sandstorms regularly sweep into the strait, reducing visibility from kilometers to zero within minutes. Navigating a 330-meter-long tanker through a 3-kilometer channel without sight is a challenge captains must face. Radar becomes the only eye, yet even it can be disrupted in the storm. Hundreds of oil tankers operating simultaneously, burning low-grade heavy fuel, create a persistent haze over the strait. Combined with high humidity from the sea and desert sand, the air becomes dense and hazardous. It is one of the most polluted marine regions on the planet. A supertanker requires 3 to 5 kilometers to come to a full stop. In Hormuz's narrow 3-kilometer shipping lane, that means there is no margin for error. Captains must make split-second decisions, relying on years of experience and nerves of steel. A single collision could sink hundreds of millions of dollars and trigger a devastating oil spill in these confined waters. At the gateway of the strait, Hormuz Island appears like a work of art from above. Vivid red soil rich in iron oxide, interwoven with streaks of white, yellow, purple, and orange. It is known as the Rainbow Island. Beneath these extraordinary colors lies a history of thousands of years, when this region was once a global trade hub. The people of Hormuz do something few places in the world can claim. They eat the earth. This red soil, rich in iron oxide and minerals known as galak, is mixed into bread, used as a seasoning, or even eaten on its own. It is not poverty, but a unique culinary tradition deeply connected to the island's unusual geology. Every morning, fishermen set out to sea on small wooden boats, following traditions passed down for centuries. And every morning, they share the water with steel giants over 300 meters long, carrying oil for the global economy. Two worlds could not be more different, yet they coexist on the same narrow stretch of water. Bandar Abbas, a city of 500,000 on the northern shore, exists because of Hormuz and lives through it. Its port is Iran's main trade gateway, where goods from around the world arrive and Iranian oil flows out. For the people here, geopolitics is not abstract. It is their jobs, their income, and their daily lives. As the sun sets behind anchored oil tankers, Hormuz reveals a breathtaking beauty, red, orange, and purple blending across the calm sea. It is a moment where grandeur and fragility coexist. The pure beauty of nature, and beneath it, the ever-present tension of geopolitics. Saudi Arabia and the UAE have built pipelines across the desert to reduce dependence on Hormuz. But their total capacity can only handle about 20% of the required oil flow. The remaining 80% has no route except the strait. And building more pipelines? It would cost hundreds of billions of dollars, take decades, and face nearly insurmountable terrain challenges. In theory, tankers could reroute around the Cape of Good Hope in Africa. But that would add thousands of nautical miles, weeks of travel, and dramatically higher costs. Oil prices would rise 10 to 15% from transport alone, and the world would need twice as many tankers. It is not impossible, just too expensive to be practical. The world is transitioning toward renewable energy, but far more slowly than headlines suggest. Oil will still dominate global energy at least until the mid-21st century. During this transition, Hormuz remains irreplaceable. Dependency does not disappear overnight, it fades gradually over decades. Experts have modeled a scenario where Hormuz is closed for just 48 hours. Within the first 6 hours, global financial markets begin to tremble. By hour 24, oil prices could exceed $200 per barrel. By 48 hours, some Asian governments may convene emergency cabinets. No war is needed, just 2 days of closure. Globalization has created unprecedented prosperity, but it has also created critical vulnerabilities. Hormuz is the clearest example. A $100 trillion global economy depends on a narrow 33-kilometer strip of water. That is not strength, it is fragility dressed as prosperity. Every oil tanker that passes safely through Hormuz is the result of a delicate balance between Iran and the United States, between Saudi Arabia and its neighbors, between geopolitical calculations and economic interests. Peace here is not luck. It is the product of constant restraint, day after day. And that restraint can break at any moment. Modern civilization is built on energy, and that energy must pass through Hormuz. We have created megacities, global supply chains, and complex transport networks, all relying on the uninterrupted flow through a strait narrower than a single city. It is one of the greatest contradictions of our time. Every morning, Hormuz awakens and continues its work, quiet, unseen, yet indispensable. As long as the world needs oil and economies remain interconnected, this strait will remain a crossroads of destinies. A narrow 33-kilometer strip of water, small on the map, yet carrying the weight of an entire civilization. At sunrise, the Persian Gulf looks as if nothing has ever happened here. The surface is calm, silent, endless. But beneath that still water, beneath hundreds of meters of sediment and ancient rock, lies something that has shaped modern human history for more than a century. The Arabian Sea spans more than 3.8 million square kilometers. Most of its seabed has never been touched, fully mapped, or drilled by humans. It remains one of the least understood regions on Earth, and potentially one of the richest yet to be explored. In these shallow waters, oil has been discovered and extracted for more than 80 years. The Middle East's first oil wells lie just beneath, shallow, accessible, easy to reach. But the easy resources are running out. And human ambition is now moving farther and deeper. This is a boundary humans have seen for thousands of years without understanding its geological meaning. The color shifts because the seabed suddenly drops hundreds of meters. On one side lies the continental shelf, explored and known. On the other lies the deep ocean, where the real secrets remain. At night, the ocean guards its secrets even more carefully. No aircraft can see through it. No satellite can penetrate its depths. What lies beneath is safer than any vault on land. And that is exactly why the most critical explorations happen in silence, often under the cover of darkness. From June to September, the southwest monsoon turns the Arabian Sea into a nightmare. Waves reach up to 5 meters, visibility drops near zero, and underwater currents become unpredictable. Deep-sea exploration is limited to the remaining 8 months, and every calm day comes at a cost. 50 meters deep, sunlight still exists. Colors still exist. Life still exists. But as you go deeper, everything changes. Light fades. Colors disappear. And at a few hundred meters, it becomes a world where humans cannot survive without machines. This is what oceanographers call the twilight zone, where the last traces of light disappear. Below lies only darkness, pressure, and absolute silence. And in a place untouched by sunlight, beneath thousands of meters of cold water, ancient hydrocarbon deposits may still remain, undisturbed since their formation. At 200 meters deep, the world is completely different. Pressure is 20 times that at the surface. Temperatures drop to 7 to 10 degrees Celsius. A fine layer of sediment stretches endlessly like an underwater desert. And beneath it, Earth's geological history is recorded layer by layer. Each meter deeper represents thousands of years. This is the edge of the continental shelf, where land ends and the abyss begins. These cliffs rise hundreds of meters, nearly vertical, recording hundreds of millions of years of geological history in stone. Geologists read them like treasure maps, searching for signs of hydrocarbon traps hidden below. At 1,500 meters, pressure reaches 150 times atmospheric levels, enough to crush human bones instantly. Temperatures approach freezing. No light, almost no currents. Yet within this pale sediment, methane molecules sometimes seep upward, a signal that something lies deeper below. These bubbles are not random. Methane seepage is the clearest geochemical signal of hydrocarbons below, like smoke revealing fire. In the deep Arabian Sea, such seeps have been recorded in multiple locations. Each stream of bubbles is an arrow pointing downward, toward the answer. Hydrothermal vents reveal intense geothermal activity beneath the seafloor. This activity is part of the long process that forms oil over millions of years. Where the Earth is still hot, where the subsurface is still active, the conditions for hydrocarbon formation may still exist. Not only in the past, but even today. Each sediment layer is a page of history. Brown marks shallow, life-rich seas. Gray signals deep, oxygen-poor waters. Black layers contain organic material, the precursor to oil. Geologists read these cores and witness hundreds of millions of years unfold before them. Even in total darkness, life persists. These creatures have evolved over millions of years to survive conditions humans cannot endure. The deep ocean is not lifeless. It is a complex, fragile ecosystem. Cold water corals live at depths of hundreds to thousands of meters, without sunlight. They grow slowly, live for thousands of years, and support entire ecosystems. Yet they remain invisible to the surface world until human activity reaches them. At 4,000 meters, the seafloor is flatter than any land plane. Red sediment accumulates incredibly slowly, less than 1 millimeter per 1,000 years. This is one of the quietest places on Earth. And beneath it, seismic data suggests massive geological structures that may have never been explored. This seismic vessel is mapping what lies beneath the seabed using sound waves. Air guns fire powerful pulses downward, through water, mud, and rock, before they reflect back. This is how humans see through thousands of meters into the Earth. These streamers stretch up to 12 kilometers, longer than Mount Everest is tall if stood upright. They carry thousands of ultra-sensitive sensors, detecting vibrations far beyond human perception. A single day of data can reach millions of gigabytes, more than entire national libraries. Every 20 seconds, air guns fire, releasing pressure waves traveling at 1,500 meters per second. When they hit boundaries between rock layers, part of the signal reflects back. From this, scientists reconstruct a three-dimensional image of the subsurface. Semi-submersible rigs operate in waters up to 3,600 meters deep. From the platform, a drilling column kilometers long is lowered like a needle through water and into the earth. It is one of the most complex engineering systems ever built to find oil. The ROV is the human eye and hand in the deep ocean. Weighing several tons and protected by titanium, it connects to the surface through a thin fiber optic cable. Data and images stream back in real time with almost no delay. A movement that seems simple, but performed at 2,000 meters under crushing pressure. Operators control robotic arms with millimeter precision. This 1-meter core sample could hold answers worth billions of dollars. An FPSO processes, stores, and offloads oil entirely at sea. Can handle hundreds of thousands of barrels per day. In contested waters, its mobility becomes a strategic advantage fixed platforms cannot match. Each kilometer of deep-sea pipeline can cost over $10 million. These lines stretch hundreds of kilometers, linking wells to ships or shore. Repairing them is as complex as rebuilding a skyscraper underwater. Not every vessel at sea belongs to oil companies. Some are research ships operating quietly, collecting data never made public. And it is precisely that hidden data that raises the most questions. The Strait of Hormuz, a narrow stretch of water less than 50 kilometers wide at its narrowest point. Yet every day, around 21 million barrels of oil pass through it. Tankers move in organized lanes like highways at sea, carrying the energy that fuels the global economy. This is not just a shipping route, it is the main artery of the modern world. A VLCC, a very large crude carrier, can transport up to 2 million barrels of oil in a single journey. Stretching over 300 meters and weighing more than 300,000 tons fully loaded, these ships move slowly like drifting mountains. Their immense inertia means they require up to 8 kilometers to come to a full stop. Every day, Hundreds of these giants silently carry energy across the planet. It is no coincidence that the world's most powerful navies maintain a presence here. Every oil shipping route is a strategic corridor that must be protected. Every offshore platform is a potential target. In these waters, energy and military power are inseparable. This is conflict without gunfire. A vessel appears not to attack, but to assert presence, to signal ownership over the waters. And whenever geological data begins to reveal valuable resources, these silent confrontations become more frequent. The flames burning atop offshore platforms are flared gas. Natural gas released alongside oil but burned due to lack of transport infrastructure. From space, these flames glow like artificial stars. Each one is a clear signal oil is being extracted below. In deep waters, such flames have yet to appear, but that may soon change. On maps, maritime borders are just straight lines. In reality, they are invisible. Water does not recognize ownership. Fish do not carry passports. But when oil lies beneath disputed zones, those invisible lines become boundaries worth billions, and suddenly, they matter immensely. This is a common scene in disputed waters. A survey vessel enters a contested zone and is quickly intercepted. No weapons, no collision. Just a clear message. The data beneath this seabed is not meant to be shared. From the deck of a drilling vessel in the Arabian Sea, there is no land in sight, only endless water and sky. But beneath the ship, a drill string descends thousands of meters into the earth, searching for something that could reshape an entire region, or perhaps nothing at all. Hormuz is one of the busiest maritime routes on Earth. Hundreds of vessels pass through it daily. And if a new deep-sea oil field is confirmed to the south, that number will rise significantly. More opportunity, but also more risk. The Arabian Sea during storm season is one of the harshest environments for engineering on Earth. Waves rise to extreme heights, winds exceed 100 kilometers per hour, and underwater currents shift unpredictably. These forces can destroy any structure not built to perfection. It is one of the reasons why these deep waters remain largely unexplored. On the open ocean, every vessel is supposed to have an identity. But sometimes, there are ships that choose not to be seen. No clear flag, no AIS signal. They move through the darkness, appearing and disappearing from global tracking systems. And most notably, these gaps often occur in the deep Arabian Sea. AIS tracking systems can detect nearly every ship on Earth, but they are not perfect. Those who understand the system know exactly when and where to disappear. A vast stretch of ocean with no signals, no traces, in one of the world's most critical maritime regions. And that is no coincidence. At night, satellites reveal the truth most clearly. The Persian Gulf glows with hundreds of lights from offshore platforms and vessels. But beyond it, the Arabian Sea fades into complete darkness. No lights, no recorded activity. But in the world of energy, silence rarely means absence. it often means concealment. Beneath the surface, another world operates unseen. Military submarines move silently, collecting data, tracking signals, listening to every movement. In the deep-sea energy game, geological intelligence is as valuable as military intelligence. And nations are willing to go to great lengths to obtain it first. Sea fog hides everything, much like the world of deep-sea oil. The ships, the money, the power, it is all there. But no one sees the full picture. Each side sees only a fragment, or only what they are allowed to see. And within that fog, decisions are made that can reshape entire regions. From the Arabian deserts, massive sandstorms can sweep hundreds of kilometers out to sea, erasing visibility entirely. Surface operations come to a halt. But thousands of meters below, there is no storm, no wind. What lies beneath the seabed remains untouched by the chaos above. It has been there for millions of years, waiting. At sunset, offshore rigs appear almost beautiful, like silhouettes against a burning sky. But beneath that beauty lies a different reality. These machines drill deep into the earth, extracting resources that took millions of years to form. And every barrel brought to the surface is a piece of the past that will never return. Above the ocean, surveillance aircraft monitor every movement below. Every vessel, every platform, every anomaly is recorded. The data is analyzed, compared, and stored. In this world, almost nothing remains truly hidden, except for one thing: what lies deep beneath the seabed. From above, the Arabian Sea at dawn appears untouched by human hands. A flawless mirror reflecting a pale pink sky. Yet beneath that calm surface lie billions of tons of hydrocarbons, resting for hundreds of millions of years. The question has never been whether they exist, but who will claim them, and at what cost. The sea knows nothing of oil, nothing of money or power. Simply does what it has always done, moving, eroding, and reshaping the world. And when humanity is gone, the ocean will erase every trace. The only question is, before that happens, how much will we take? Every oil platform has an end. When the reserves run dry, these massive steel structures are dismantled, cut apart, and removed. The cost can reach billions of dollars. But what has been extracted never returns. On the seabed, only traces remain, steel memories of what once stood. Out at sea, there are moments when all boundaries disappear. Water and sky merge into a single horizon. And somewhere beneath that line, the answers remain hidden. Not in maps, not in political agreements, but within the silent layers of sediment far below. At sunset, the Arabian Sea becomes a breathtaking canvas of light, beautiful enough to make one forget what lies beneath. But as the light fades, darkness takes over. And in the depths where sunlight never reaches, the secrets remain untouched, waiting for those bold enough to uncover them. Night falls, and the ocean returns to its true nature: dark, deep, and endless. What lies beneath does not disappear. It only becomes quieter, more patient. The story of oil is not over. It is simply shifting from desert sands to ocean depths, and the seabed has not yet told its full story.
This is the darkest place on our planet. Not outer space, not a cave, not the depths of a forest. It lies directly beneath your feet, 11 kilometers below the ocean's surface. Sunlight can only penetrate the first 300 meters of the ocean. Below that lies the twilight zone, then the midnight zone, and finally, absolute darkness. Challenger Deep is 36 times deeper, where no ray of sunlight has ever reached. If Mount Everest were placed inside the Mariana Trench, its peak would still sit 2 kilometers underwater. This is the lowest point on Earth's surface. And for centuries, humanity knew almost nothing about it. More people have walked on the moon than have visited the deepest ocean. Challenger Deep is more remote than the International Space Station. And what scientists discovered there could change how we understand life forever. Scientists discovered life here. Not fragile organisms barely surviving, but entire ecosystems thriving and stranger than anything imagined on distant planets. This is the story of Earth's deepest abyss and its final mystery. The Mariana Trench lies in the western Pacific Ocean, about 300 kilometers from the island of Guam. It stretches for 2,550 kilometers, longer than the width of the United States. But its true fame comes from its unimaginable depth. Earth's surface is divided into massive tectonic plates that constantly move. Here, the older and heavier Pacific Plate dives beneath the smaller Mariana Plate, tearing the ocean crust apart and forming the deepest scar on the planet. What makes the Mariana Trench so deep is the age of the ocean crust. It is 170 million years old. Dating back to the age of dinosaurs. Older crust is colder, denser, and sinks deeper into the planet. From the surface to 200 meters lies the sunlight zone. Home to dolphins, sharks, and coral reefs. Below 1,000 meters begins the midnight zone, where darkness and crushing cold dominate. But beyond 6,000 meters lies the tidal zone. A strange world where pressure reshapes the rules of life itself. The pressure at Challenger Deep is more than 1,000 times stronger than at sea level. It's like placing 50 Boeing 747 airplanes on an area the size of your fingertip. Any object not specially reinforced would be crushed instantly. Temperatures at the bottom range between just 1 and 4 degrees Celsius, nearly freezing. No sunlight reaches this depth, and no warm ocean currents can penetrate it. This is the coldest, darkest, and most silent environment on Earth. You sit inside a steel sphere, smaller than a refrigerator. Outside, 11 kilometers of freezing seawater press against every centimeter of the hull. And the only sound you hear is the metal creaking under unimaginable pressure. On January 23, 1960, two men prepared to attempt something no one had ever done before. U.S. Navy Lieutenant Don Walsh and Swiss engineer Jacques Piccard were about to descend to the deepest point on Earth. The Trieste was unlike any submarine ever built. Above sat a massive tank holding 85,000 liters of gasoline for buoyancy. Below hung a steel sphere 12 centimeters thick, barely 2 meters wide. No cameras, no robotic arms, no rescue system. Just two men and a mission. The descent lasted 4 hours and 47 minutes in total darkness. Walsh and Piccard could see nothing, only hearing the water, each other's breathing, and the creaking of metal. Then, at 9,000 meters, a terrifying bang echoed through the hull. A plexiglass window on the outside had cracked under pressure, shaking the entire vessel. Walsh and Piccard faced a choice: ascend immediately or continue descending deeper. They looked at each other and made their decision: to keep going. At 1:06 p.m., the Trieste touched the bottom of Challenger Deep at a depth of 10,916 meters. The temperature inside the cabin had dropped to just 7 degrees Celsius. Exhausted and shivering, they had only 20 minutes before beginning the ascent. Piccard reported seeing a flatfish about 30 centimeters long gliding slowly across the sediment. Then small shrimp appeared, movement, life. Perfectly ordinary life at the very bottom of the abyss. Challenger Deep was not empty. Something was living there. After that historic dive, no one returned to Challenger Deep for more than 50 years. The Trieste carried no cameras and collected no samples. 2 eyewitness accounts were the only evidence. The US Navy abandoned the effort. The cost was enormous, and the scientific return seemed too small. Scientists shifted to using remotely operated vehicles, or ROVs. These machines could send back images and samples, but they lacked the flexibility of human exploration. The Mariana Trench remained largely forgotten until a Hollywood director entered the story. On March 26, 2012, filmmaker James Cameron climbed inside the submersible Deep Sea Challenger. The director of Titanic and Avatar was about to descend alone to the deepest point on Earth. This time, there were cameras, scientific instruments, and tools to truly study the abyss. Cameron sat inside a cockpit so cramped he could barely stretch his arms. A window 24 centimeters thick separated him from the crushing pressure outside. After 2 hours and 36 minutes, he became the 3rd human in history to reach Challenger Deep. Cameron described the landscape as desolate, almost like the moon. No large animals appeared, yet the sediment samples he collected revealed 68 previously unknown species of microbes. Cameras also captured microbial mats thriving through chemosynthesis, life that survives without sunlight. In May 2019, American explorer Victor Vescovo reached a record depth of 10,927 meters. But he did not stop after one dive. Vescovo returned repeatedly, allowing humans for the first time to systematically explore the deepest part of the ocean. Vescovo's team discovered rocks coated in vivid yellow and orange minerals, evidence of deep geological activity. They also identified 4 new species of amphipods, shrimp-like creatures perfectly adapted to the crushing pressure of the abyss. Then, Vescovo saw something no one wanted to find in the deepest place on Earth. Resting on the floor of Challenger Deep, nearly 11 kilometers below the surface, was a plastic bag and candy wrappers. He later described it as the most disappointing moment of the entire expedition. Scientists brought the captured deep-sea creatures back to the laboratory and analyzed their tissues. The results were shocking. Nearly every animal examined contained microplastics. Plastic from the surface had sunk 11 kilometers down, and the creatures here are consuming it. This discovery shocked the scientific community. No part of the ocean, no matter how deep or remote, remains untouched by human activity. The Mariana Trench is not only the deepest place on Earth, it has also become a mirror reflecting humanity's impact on the planet. The Mariana snailfish is the deepest living fish ever recorded, surviving at depths beyond 8,000 meters. Its body is almost transparent, lacking a swim bladder and built mostly from soft cartilage. It represents the absolute limit of vertebrate life on Earth.
Yet home to some of the planet's most unreal ecosystems.
Giant amphipods, relatives of shrimp, can grow up to 18 centimeters in the Mariana Trench. Scientists discovered they reinforce their exoskeletons with aluminum, something no other known animal does. They extract the metal directly from deep-sea sediments. The Dumbo octopus, named for its ear-like fins, is one of the deepest living octopus species known. Unlike shallow water octopuses, it lacks an ink sac. At these depths, predators are rare, so elaborate defense mechanisms are unnecessary. Xenophyophores are the largest single-celled organisms ever discovered. A single cell can grow to the size of a tennis ball. Spread across the ocean floor like alien flowers, they challenge many biological assumptions about the limits of life. Between August and November 2021, China's Fendaosia submersible completed 33 dives into the Mariana Trench. Scientists collected more than 1,600 sediment samples and discovered over 7,000 microbial species, nearly 89% of them previously unknown to science. Thousands of tube worms and giant clams form dense colonies on the trench floor, resembling an underwater forest. These organisms survive through chemosynthesis, using chemical energy leaking from the Earth's crust instead of sunlight. It is the deepest chemosynthetic ecosystem ever discovered. The Mariana Trench teaches us something extraordinary. Life does not require sunlight, comfortable temperatures, or the conditions we once believed were essential. But it also teaches us something else. No place on Earth is truly beyond the reach of humanity. Even 11 kilometers beneath the ocean's surface, our presence can be found. The darkest place on our planet is still waiting to be explored. The only question is this: when we return, will we bring science or more pollution? look at the ocean's surface and think you are seeing the Atlantic, but that surface is only a curtain, a thin sheet of glass separating our world from an entirely different one below. "99% of this ocean's volume exists where there is no light, no warmth, no familiar sound, and yet it is still full of life."
With every meter you descend, something changes. Light weakens, colors disappear in sequence. Red first, then orange, yellow, green. Only blue remains. Then violet. Then nothing. Darkness does not arrive from one direction. It comes from everywhere at once, slowly and completely consuming everything.
Before we descend deeper, look at the smallest life in the upper layer, phytoplankton. Single-celled organisms invisible to the naked eye produce more than 50% of the oxygen in Earth's atmosphere. Not rainforests, not the Amazon. These microscopic drifters, suspended in the top 200 meters of the Atlantic, are what keep you breathing.
This is a bait ball. Millions of herrings gather into a dense sphere and move as if they were a single organism. No leader, no central command. Each fish reacts only to its nearest neighbor, and from millions of simple decisions emerges a collective intelligence powerful enough to deceive sharks and tuna for hours.
Funnus finis, the Atlantic bluefin tuna. 3 meters long, weighing over 600 kilograms, capable of bursts up to 70 kilometers per hour. They are warm-blooded, rare among fish, maintaining a body temperature higher than the surrounding water to maximize muscle performance. Each year they migrate from the Caribbean to Norway and back, tens of thousands of kilometers with no maps, no GPS, guided only by Earth's magnetic field.
Dolphins are not just intelligent, they have names. Each dolphin produces a unique signature whistle, like an acoustic fingerprint, and others in the pod call them by it. They remember companions after years apart. They teach their young hunting techniques through demonstration. The Atlantic is home to minds like these, right at the surface, right before our eyes.
Dermacheles coriacea, the leatherback turtle, the largest living reptile, weighing up to 900 kilograms. They dive deeper than 1,200 meters to hunt jellyfish, prey they pursue across the Atlantic. This species has existed for 100 million years, surviving the extinction that wiped out the dinosaurs. And now, they face the greatest threat in their history, us.
Cyanea capillata, the lion's mane jellyfish, one of the longest animals ever recorded, its tentacles stretching up to 37 meters, longer than a blue whale. No brain, no heart, no blood, a body made of 95% water. And yet, it hunts, reproduces, and has existed for 500 million years, long before fish first appeared on Earth.
The Sargasso Sea is the only sea on Earth without a shoreline, its boundaries defined by 4 surrounding currents. The floating mats of golden sargassum form a complete ecosystem. Hundreds of species cling to it, hide within it, feed upon one another, entirely dependent on this drifting forest. It is also where European eels travel over 6,000 kilometers to spawn and then die.
"200 meters. Sunlight officially ends here. Above is the world you know. Below is a world humanity has only just begun to glimpse. More than 80% of the ocean floor has never been directly observed. What we are about to enter, much of it is being told for the first time. Let's keep descending."
The mesopelagic layer, also known as the twilight zone, stretches from 200 to 1,000 meters. This is a realm of perpetual dusk, where day and night lose their meaning, and light becomes only a faint memory from above. Few people realize this zone holds the largest animal biomass on the planet, more than all surface fish combined, yet we know almost nothing about it.
Myctophody, lanternfish. These tiny fish, only a few centimeters long, may be the most abundant fish on Earth by total biomass. Each night, they rise to the surface to feed. Each morning, they descend into darkness to avoid predators. This vertical journey of hundreds of meters, repeated every 24 hours, is the largest migration on the planet, and almost no one knows it exists.
A siphonophore is not a single organism, but a colony. Thousands of tiny individuals called zooids are linked together. Each evolved to specialize in a single task: hunting, digestion, reproduction, propulsion. None can survive alone. It represents one of the most blurred boundaries between individual and collective in the natural world, and some species grow up to 50 meters long.
Vampiroteuthis infernalis, the vampire squid from hell, a scientific name that lives up to its meaning. Neither true octopus nor true squid, it is the last surviving member of an ancient evolutionary lineage. When threatened, it turns itself inside out like a cloak, exposing sharp spines, and releases not black ink, but clouds of bioluminescent light, turning darkness into illumination.
Humboldt squid communicate by changing the color of their skin. Millions of chromatophores expand and contract in an instant, producing complex flashing signals we have yet to decode. They hunt cooperatively, coordinating attacks without sound, using only light. It is a complete language, written on skin, read by sight, in total darkness.
Regalachus glesnae, the oarfish. Reaching up to 11 meters, it is the longest bony fish on Earth. For centuries, oarfish appearing near shore were believed to signal earthquakes and tsunamis, not entirely without basis, as they inhabit tectonic fault zones. They were never filmed alive in their natural habitat until 2001. Before that, we only knew them from bodies washed ashore.
Marine snow. The remains of phytoplankton, animal waste, mineral shells of microorganisms all clump into tiny particles and fall continuously from the surface. It is the only food supply for life below the light zone. But marine snow is also a carbon pathway, carrying atmospheric CO2 to the ocean floor. The Atlantic is absorbing humanity's carbon and burying it for thousands of years. Every second, every day.
Isurus oxyrhynchus, the short-fin mako shark, the fastest shark in the ocean, reaching 70 kilometers per hour and leaping up to 6 meters above the surface. Like the bluefin tuna, makos are warm-blooded, maintaining elevated body temperatures to maximize muscle and brain performance while hunting. They can detect prey movement through electroreceptors across their snouts.
Every night at sunset, an extraordinary event unfolds across the global ocean. Billions of organisms, lanternfish, shrimp, small squid, copepods, rise from the depths to feed at the surface, then descend before dawn. This vertical migration moves vast amounts of carbon from surface waters to the deep ocean each night, one of the most important mechanisms regulating Earth's climate, and we are only beginning to understand it.
Copepods, smaller than a grain of rice, may be the most numerous animals on Earth. Trillions are drifting in the Atlantic right now. They are the central link in the entire marine food web, feeding on phytoplankton, eaten by small fish, and ultimately sustaining whales. If copepods disappeared, the ocean ecosystem would collapse within weeks.
Architeuthis ducks, the giant squid, growing up to 13 meters long with the largest eyes in the animal kingdom, 27 centimeters wide, the size of a dinner plate, designed to capture the faintest photons in the darkness. For centuries they were legend, the Viking kraken, the sailor's sea monster. Not until 2004 were they first photographed alive in their natural habitat, and much about them remains unknown.
During World War II, the US Navy discovered something strange. Sonar repeatedly misread the ocean floor. They called it the false bottom. Later, scientists realized it was the deep scattering layer, a dense concentration of organisms reflecting sound waves like solid ground. Billions of creatures gathered at the edge of light, forming a biological layer so thick, sonar mistook it for rock. War had accidentally uncovered one of the greatest ecological phenomena of the ocean.
"1,000 meters. Sunlight does not exist here. Not a single photon from the sun reaches this layer. Temperature, 4 degrees Celsius. Pressure, 100 atmospheres, 100 times surface pressure. This is the bathypelagic zone, the realm of true darkness, stretching from 1,000 to 4,000 meters, and it holds more mysteries than everything we have discovered above."
Melanocetus johnsoni, the black anglerfish. The female carries a biological lure on her head, its tip filled with bioluminescent bacteria, the only trap she needs. Prey approaches out of curiosity or mistake and disappears into elastic jaws capable of swallowing something twice her size. Her stomach can expand almost endlessly. In this darkness, you never know when the next meal will come.
Male anglerfish are up to 60 times smaller than females. When he encounters a female, he bites into her skin and begins to fuse, circulatory, nervous, and digestive systems gradually connecting before dissolving. Eventually, the male is no longer an independent individual. He becomes an appendage of the female, existing only to provide sperm. This is one of the most extreme forms of biological integration in nature.
Dragonfish possess a weapon no prey here is prepared for: infrared light. Most deep-sea creatures cannot see infrared because evolution never created sensors for something absent from their environment. Dragonfish use it as a stealth flashlight, illuminating prey without the prey knowing it is being lit. They truly see in the darkness, while everything around them remains blind. Macropinna microstoma, the bear eye fish. Its head is completely transparent, like a diving helmet, allowing its tubular eyes to rotate freely inside, looking upward to detect faint backlit prey silhouettes, then rotating forward to strike. We did not know this until 2004, because bringing them to the surface shattered the transparent dome. For decades, we described the species incorrectly. Chaliotis sloani, the viperfish. Fangs so long it cannot close its mouth, curving outward to form an inescapable trap. Along its belly, photophores emit light matching the faint glow from above, allowing it to disappear when viewed from below. In this darkness, even darkness itself becomes a weapon. Grimpeteuthis, the Dumbo octopus, lives between 1,000 and 7,000 meters, the deepest living octopus known. Its body is nearly transparent, lacking an ink sock because concealment is unnecessary where there is no light. They do not follow seasonal reproductive cycles like surface species. Females carry eggs and can lay them year-round when conditions allow. In eternal darkness, time operates differently. Himantolophus, the deep-sea football fish. Its round body is an adaptation, no streamlined scales for speed, because speed does not matter here, energy conservation does. It barely swims, hovering and waiting. Its lure emits silver light, different from the common blue, attracting prey accustomed to blue glows. In the darkness, even the color of light is strategy. In absolute darkness, some species evolved in the opposite direction. Instead of dark camouflage, they became transparent. There is nothing to see as light passes through like air. This is the most perfect invisibility possible, not by blending into the background, but by erasing one's shadow entirely in a world without light. Mantis shrimp can strike with acceleration faster than a bullet, 23 meters per second in under 3 milliseconds. The punch creates cavitation bubbles, low pressure bubbles that collapse at temperatures as hot as the surface of the sun for a fraction of a second. Even if the direct hit misses, the shockwave can kill the prey. They carry a miniature nuclear-level physical weapon in their claws. Deep-sea hatchetfish practice camouflage known as counter-illumination. Their bellies glow through photophores at precisely the same intensity as the faint light from above. Viewed from below, they vanish into the background and cast no shadow. Predators see nothing. It is optical stealth technology, perfect, battery-free, evolved over millions of years. Acanthostir plancy, the crown of thorns starfish. Not a deep-sea species, but a perfect example of how one species can destroy an entire ecosystem. Each individual consumes coral. During outbreaks, they blanket and eliminate entire reefs in months. Ecosystems built over centuries erased in a single season. And outbreaks are becoming more frequent as oceans warm. Samniosis microphycephalus, the Greenland shark. the longest living vertebrate known on Earth. Radiocarbon analysis of islands tissue suggests one individual lived over 400 years, born before Galileo invented the telescope. They grow so slowly, they reach sexual maturity only at 150 years. In 2 degrees Celsius water, time literally moves slower. Sperm whales dive to 2,000 meters and can hold their breath for over 90 minutes. In total darkness, they hunt giant squid using echolocation, producing the loudest clicks in the animal kingdom, 230 decibels, powerful enough to stun or kill prey before contact. Many sperm whales bear large circular scars, marks left by giant squid tentacles in battles no human has ever witnessed. Stillness is the most effective hunting strategy in darkness. Many species here never actively chase prey. They wait, day after day, month after month, hovering or lying motionless, consuming minimal energy. When prey comes close enough, in an instant. Where food is scarce and energy more precious than gold, patience is not a virtue, it is survival. 4,000 meters. The seafloor, not rock, but mud. Fine sediment tens of meters thick, accumulated from marine snow over millions of years. This is the abyssal plain, the flattest and most extensive terrain on Earth, stretching thousands of kilometers unchanged, silent, dark, and cold. And still, life exists here, though no one knows exactly what kind or how much. 3,800 meters beneath the Atlantic, 700 kilometers from Newfoundland. RMS Titanic has rested here since the night of April 15, 1912. But this is no longer just a wreck. It is a complete ecosystem. Coral clings to the railings, fish move through corridors once filled with people. Octopus inhabit rooms that were once first-class cabins. Halomonas titanica, bacteria named after the ship itself, are consuming Titanic from within. They feed on iron, excreting intricate rust formations called rusticles, up to 90 centimeters long, housing entire microbial communities inside. Scientists estimate Titanic may fully collapse within the next 30 years. The ship is being slowly digested by millions of invisible organisms. In 1912, this was the most luxurious ship ever built. Crystal fountains, grand staircases, private refrigeration for each cabin. Now, nothing remains. Wood consumed by bacteria, carpets and curtains dissolved, only metal and mud endure. Yet within that mud, thousands of objects remain intact. Leather shoes, wine bottles still holding wine, silverware still gleaming in ROV light after more than a century. From the 15th to 18th centuries, hundreds of Spanish galleons carried gold and silver from the Americas to Europe, and many never arrived. Storms, reefs, pirates, the Atlantic took its share. Billions in treasure may still lie undiscovered in these wrecks, yet more valuable now, they have become coral reefs, habitats for hundreds of species that could not survive without them. The U.S. East Coast from Florida to Cape Hatteras. Sailors in World War II called it Torpedo Junction. German U-boats hunted here from 1942, sinking hundreds of ships within months, sometimes within sight of shore. Now the wrecks of U-boats and Allied vessels lie side by side beneath the sea, coral covering both, hostility dissolved in time. SS Thistlegorm, a British military supply ship bombed in 1941, sank with its cargo intact. Trucks, motorcycles, rifles, boots, boxed watches. Today, everything remains as it was loaded, neatly arranged yet covered in coral and anemones. Fish swim through motorcycles like a forest. War created a sanctuary. Henrietta Marie, a British slave ship wrecked in 1700 off Florida. When divers found it in 1972, they discovered hundreds of iron shackles scattered across the seabed. An estimated 200 Africans were chained in its hold when it sank. This wreck stands as physical evidence of one of humanity's darkest chapters, resting silently beneath the Atlantic for 3 centuries. Not only ships, the Atlantic is also a graveyard for thousands of aircraft. B-17 bombers flying from America to Britain often ran out of fuel and ditched at sea. Crews were rescued, the planes were not. Now these flying fortresses lie on the seabed like rusted steel monuments, cockpits intact, tail guns still facing backward, waiting for enemies that will never come again. In 1968, the U.S. nuclear submarine USS Scorpion disappeared en route from the Mediterranean to Norfolk. 99 sailors never returned. It was found that same year at 3,000 meters, shattered into pieces. The official cause remains unresolved after more than 50 years. The Atlantic keeps its secrets. The most remarkable thing about these wrecks is not that they sank, but what happened afterward. Hard metal in soft sediment is a rare resource, an anchor point for coral, anemones, mussels, oysters. When coral grows, fish arrive. When fish arrive, larger fish follow. Within decades, a wreck becomes one of the most biodiverse sites in surrounding waters. Human tragedy becomes nature's sanctuary. Modern technology is transforming how we approach these graveyards. ROVs can descend to 6,000 meters, film in high resolution, collect samples without touch. Wrecks once unreachable are now mapped in full 3D by sonar. Yet for every wreck discovered, hundreds remain unknown, lying silently in darkness, waiting. An estimated 3 million shipwrecks lie on the ocean floors, most within the Atlantic. Each wreck is a story interrupted, a journey never completed. Yet, from another perspective, the Atlantic has preserved over 3 million physical records of human history under near-perfect conditions. The ocean does not only take, it also keeps. In the oxygen-poor mud of the Atlantic seabed, ordinary decay bacteria cannot function. Many organic materials are preserved almost perfectly. Leather shoes from Titanic still hold their shape after more than a century. Leather, fabric, wood would normally vanish, but here, time moves slower. Decay proceeds differently. The deep seafloor is the most perfect archive on the planet.
The oldest wrecks in Atlantic-adjacent waters, Greek, Roman, Phoenician amphorae, remain intact after 2,000 years. Inside some amphorae, traces of wine, olive oil, honey